A traffic group is a collection of related configuration objects that run on the big IP device. Together, these objects process a particular type of traffic on that device. When a device becomes unavailable, a traffic group floats or fails over to another device in the device group. This ensures that application traffic continues to be processed with little or no interruption to the service. Only certain types of configuration objects can belong to a traffic group. Examples are self-IP addresses and virtual IP addresses. Traffic groups contain failover objects, such as a virtual address or a floating self-IP. Another way to describe failover objects is they are all ARP-able objects, so SNATs and NATs also fall into this list. Here is where to configure traffic groups. You can see a list of some failover objects. From the Network tab, select Traffic Groups. Within a sync failover type of device group, each device has a specific designation with respect to a traffic group. That is, a device in the device group can be a default device and a current device or a backup device. This is how we configure the traffic group. From the Virtual Servers tab, we can click on Virtual Address List, then select the traffic group. A default device is the device on which you want a traffic group to run if possible. You actively specify a default device for a traffic group when you create the traffic group. When a traffic group floats due to failover, the Big IP system selects the default device as the target failover device, whenever that device has the same availability as other group members to process traffic. You can specify a default device, but not a backup. This is okay and will be discussed more in a few slides when we discuss the score. In an N+1 concept, if more than one device fails and those devices do not come back, then the remaining devices may have too much workload to process. If devices do come back online, then workload is distributed according to the score, which is discussed in a couple of slides. There is an auto failback setting for traffic groups, which would push the traffic group back to the default device when it returns back to a standby state. A better design would be enough big IPs, each being able to handle a certain amount of traffic, which is split across multiple traffic groups. If one device has problems, then no one big IP is overwhelmed with too much traffic. There is iQuery communication happening all the time between members of a device group, not only to sync the config, but also to determine the failover score. When one member of a device group fails, the member with the highest failover score will receive the workload or traffic group from the failed device. Of course, this failover score is always being recalculated based on the amount of traffic, type of big IP device, 1600 or Viprion, and the percent of CPU and memory utilization. In other words, all members of a sync failover device group will always know which member is responsible for picking up workload in the event that one member fails or stops communicating with the group. When more than one device is active for a traffic group using the same application nodes, then at least one of the device's node traffic must use SNAT for routing to work correctly. The application node can point to a floating IP address for one traffic group, but for traffic to flow appropriately through a second, third, or additional traffic group to the same nodes, that traffic will need to be SNATed so that response traffic flows back through the correct big IP device. Customers were discouraged from running the big IP in active-active mode prior to version 11.